Hello and welcome to part 6 of Dev Maths and Stats Refresher course, lecture 3. So let's look at some examples of maximising profit. So here we've got a common thing that takes place in some rural areas of people, as well as doing their agricultural activities, they're making money in other ways. So a woman here is selling some grass mats, but she's doing two different sorts. She buys plain ones and sells them from local weavers and sells them after the harvest when local people have got money. But she also buys some more highly decorated ones and she sells those in the nearby town for tourists and maybe wage earners and others in the town at a higher price. And we've got two different demand functions here. In the town, in the rural area, the demand for her mats is given by this, and in the town by this. So just think to yourself, does the form of the function make sense? If the quantity of the ones she sells in the rural area goes up, so this increases, then she's going to sell fewer. The price needs to be lower, so the price goes down in the rural area. So as the quantity goes up, the price goes down, which is what you'd expect. Well, if you increase the price, then the quantity goes down. And similarly, in the ones she's selling to the tourists, QT, to sell more of those, the price needs to go down. So these are the price function, the demand functions. And here we've got the total cost. So cost is 5,000 plus 4QR squared plus 10 QT squared plus QRQT. And the obvious question is, how many should she buy to sell in the local market and how many in the tourist market if she wants to maximise profits? So before we answer it, make sure you understand the shape of the function I just talked about there, the demand function, why it's like that. What other factors might affect this? Because as soon as you start presenting this in a seminar or something, people are going to say, well, there's other factors might come into it, so what are they? But coming back to this function, the specification here, what's this 5,000 for? Think about that. And what's this for? So if you pause the video for a second, think about what the 5,000 is and why there's this term where they're multiplied like this. So the 5,000 here is here to represent a fixed cost. So even if she sets QR and QT to 0, so she has no business or mats at all in some particular week or year, then she still has to pay 5,000. So it could be that she's renting a warehouse or some space to do the work in, for example. And the reason why these are here is slightly more subtle, in that if she increases the number that she's buying, say for the tourist market, that doesn't really have any effect on the cost impact if she decides to increase as well in the rural market. They're completely independent. So the impact on her costs from increasing the rural sales is independent of how many she's selling in the tourist sales and vice versa. Except this modifies it a bit. This says that if she sells lots in the tourist market, then that makes it more expensive for her. It increases the impact from adding to the sales in the rural market and vice versa. So there's an interaction effect, and you'll see this again in econometrics, an interaction effect between these two things. So that's what that term means. Okay, let's just look at how we solve this. So what you want to do is to make each market make marginal revenue equal to marginal cost. And that gives you two simultaneous equations to solve. So first of all, we need a revenue function, and revenue is price times cost. So just restart this and define the function we have already. So total revenue is that's the price in the rural market from up here. That's the price in the town market or tourist markets. So multiplied by the quantities in each market, you have the total revenue. And then this is expanding out. Just notice there's a command here that will do that. And then the total cost is all we already have. Then you partially differentiate all of this stuff up here. So this is the marginal revenue of, well, let's just see what it will look like. So you should be able to do this all by hand. I'm doing it quickly on my computer. You should, from what happened in the lecture, be able to see how to get this. So if that's the marginal revenue for selling in the rural area, you differentiate this with respect to QR, and you should be able to find this quite easily. Then differentiate this one with respect to T. So that's straightforward differentiation. And then this one here is really partial differentiation. So this is the total cost. So differentiate this with respect to QR to find the impact of selling one more in the rural market. So that's, this differentiates to the A to QR. This differentiates to just QT. And this is just constant, and this is just constant. So they disappear and you get this. And for the town, you get, similarly, you get this. And then you simply say, equate marginal revenue with marginal cost in R and T, and you get like this. A bit of rearrangement to make it equal to 0. So I say that this is equal to this is the same as saying this minus this is equal to 0. So, and then you have two simultaneous equations here. I think I've decided here to solve this by elimination method, because I spotted here we have to QR. So if we multiply this equation by 18, then we have 18QR, 18QR. So it should pan out fairly nicely. So that's equation 9 times 18. And then you just subtract these two equations. So this subtract this one. And you find that QR has been eliminated. And then you can just rearrange and get the solution for that. So that gives you QT is equal to this. Then substitute that back into the other equation, equation 9. And solve that. And you find that QR is this horrible fraction. Check, because I substitute into Q9, I then check this in the other equation, equation 10, to make sure it works. So it does, this is correct. And then, because these numbers are quite hard to read, just using this function makes you see the decimal form. So the decimal form is like this. So what this is telling us is, to maximise the profit, she needs a fairly even split. So roughly 100 in the rural market and a few more than 100, about 106 in the tourist market. That will maximise her profit. Okay. So please, questions in the live session, if any of that's not clear. Then after this, we'll go on to the topic of elasticities in the next video. So thanks for watching.